Okay, so we're back to chapter 22 now to try to finish this off. So we're on to part C of it. We looked at the introduction to organic chemistry, alkanes, alkenes, alkynes. We've looked at fuels, and now we're going on to part C, thermochemistry. So this is looking at chemical reactions, and basically what a chemical reaction is breaking bonds and forming new bonds to make new substances. In order to do this, energy is needed to break the bonds, and energy is released when bonds are formed. So breaking bonds requires energy, and when bonds are formed, they produce energy. Energy is released from them. So this means that there's a change in energy that goes with every chemical reaction, and it's mainly in the form of heat, and that's what we're going to be looking at in this chapter. So you've heard the words exothermic and endothermic reactions before, and we're just going to go into a little bit more detail on them now and what that means as we go through this part of the chapter. So exothermic reactions are reactions which give out heat, so heat is produced, and endothermic reactions are reactions where heat is taken in. So that means that the reaction absorbs heat. The study of these heat changes during chemical reactions is what is known as thermochemistry or chemical thermodynamics. So the first thing we need to look at is the heat of reaction. Now you'll recognize the delta H symbol here, that we've seen that before in identifying endothermic and exothermic reactions, and we're going to break down what it is now. And what it is that it's the change in heat that takes place during a reaction. So delta, anytime you see the symbol delta, that's going to mean a change, and heat is standing for the heat of the reaction. So the energy changes to do with heat during the reaction. So we saw when we were looking at fuels that hydrogen fuel burns in oxygen to form water. And after a lot of our reactions, we see this written after them, a delta H value. So that's a heat of reaction value. And what that means is the 242 tells us that 242 kilojoules of heat are released. The negative sign indicates that heat is taken away or has left the reaction. So that's a reaction that's producing heat. So the minus sign there is that there was more heat energy in the flask before the reaction started. It's producing heat, and we say that heat is moving into the surroundings, so it's heating up the flask. It'll heat up your hands if you put your hands around the flask. So it has left the reaction, and therefore it's an exothermic mixture. So to summarize that, an exothermic reaction, and that is when the delta H is negative, and an endothermic reaction is when the delta H is positive. So the heat of reaction, the change, is positive for endothermic reactions. The units of heat of reaction are in kilojoules per mole. So we mentioned already up here the kilojoules, and that's the unit of energy. So the SI unit, the standard unit for energy, is joules, and because one joule is very, very small, we do it in terms of kilojoules just to make the numbers easier to manage. This would be 242,000 joules. So it's just to make the number easier to manage. And the fact that it's mole to the power of 1, that means per mole. And this indicates that the heat of the reaction is measured per mole of the substance reacting. So the substance reacting here is hydrogen. It's being burned in oxygen, so we have a combustion reaction. And you can see there's a 1 in front of the hydrogen here. Our balanced equation is 1H2. So we have 1 mole of hydrogen. That's very important, because if you were to do it with 2 moles of hydrogen, so a lot of the time when we balance our equations, we try to get rid of the fractions. In this case, we're not worried about that, because if we multiply this reaction by 2 to get rid of the fraction, we also have to multiply the delta H value by 2, because now this is 2 moles of hydrogen rather than 1. So we're doubling the amount of hydrogen, therefore we're doubling the amount of heat produced. So this equation here is known as a thermochemical equation. Again, forgot the E in there, a thermochemical equation. The physical state, so the small g's here, they all represent gas. So it's hydrogen gas reacting with oxygen gas, and it's going to be making steam. So steam is water as a gas. The reason those are shown is because if we were to change the state, if we were to use hydrogen liquid, for example, that would alter the value of the delta H produced. So it's important in these, you'll see G, L and S, so for gas, liquid and solid. The other thing you might see is AQ, which stands for aqueous. So if it was H2 and we had an AQ down here, that would mean it's hydrogen gas dissolved in water. So your definition for heat of reaction, to summarize, is the heat change when the number of moles of reactants indicated in the balanced equation for the reaction react completely. So there, that is the general definition. So that's taking into account that if you have 2 moles, then the heat of reaction number, the value that's given, is for that amount of moles to react. So it's when the number of moles of reactants indicated react completely.